Here's an example of a different kind of equation than we've solved before. This particular equation contains a radical expression. Here we have the square root of 3x minus 2. When you're confronted with an equation with a radical expression, what you want to do in order to solve for the variable that's contained there in the radicand of that radical expression is you want to, first of all, isolate the radical expression on one side of the equation if it's not already isolated. In this case, our radical expression is isolated from any other terms in the equation. Then what you want to do is you want to raise the radical expression to a power that will undo the root. Since this is the square root, the power that would undo the square root would be the second power. So in this case, what I want to do is I want to square that radical expression. But of course, if I square one side of an equation, I would have to square the other side of the equation to keep my equation balanced. Now, there is some danger with this approach to solving a problem this way. One of the problems, you know that when you square a positive quantity, of course you produce a positive quantity. But when you square a negative quantity, you also produce a positive quantity. So we have to be a little careful with this technique. It's the technique we want to use, but it has some pitfalls. One of the things we must do in equations like this is whatever solution we get, we must put it back into the original equation and test it to make sure that by squaring both sides, as we're doing here, we haven't introduced a solution that really isn't a solution, or the fancy math term is an extraneous solution. So this kind of problem requires us to check every solution we get to make sure it truly is a solution. Well, now, if we square the square root, that simply gives us the radicand. In this case, the radicand is the binomial 3x minus 2. Squaring 5, we get 25. And what we have created now, from this radical equation that we had, we have created a linear equation in one variable that we can solve. We'll add 2 to both sides here. Divide both sides by 3. And we're saying that the solution to this equation is 9. And again, whenever you get a solution to a radical equation, you must check that solution in the original equation. So I need to replace x with 9 in the original equation. To be sure that indeed this left-hand side becomes exactly the same as the right-hand side. Well, 3 times 9 is 27. 27 minus 2 is going to give us 25. And remember, when you simply have a radical sign with no sign in front of it, by sign I mean either a plus sign or a minus, you are talking about the positive square root only. You're not talking about the potential to have the negative square root, only the positive square root. So the square root of 25 is 5, and indeed we have demonstrated that the solution we found is a valid solution and not an extraneous solution. So this is a technique we use when we're solving what are called radical equations. Isolate the radical expression, raise it to the power that will undo the root, making sure to raise the other side of the equation to the same power, and then solve the resulting equation.